This satellite image shows a terrestrial hurricane grinding against the North American coastline. The boundary where the storm's vortex meets the landmass acts like a brake, creating immense friction that starves the system of energy and strictly limits how large it can grow. But if you remove the land entirely, the physics of weather change. Look at Jupiter, a massive planetary engine composed entirely of hydrogen and helium gas. There is no solid crust to break up the wind. Without surface friction dragging them down, swirling air masses can feed on themselves and expand until they swallow entire latitudes. To see the absolute physical limits of atmospheric violence in our solar system, we must leave our terrestrial assumptions far behind and descend directly into the violent heart of the Great Red Spot. Approaching the outer perimeter, the storm rises out of the surrounding cloud deck like an impenetrable wall. The sheer surface area is staggering. The diameter of this vortex stretches roughly 10,000 miles across. This animated comparison puts that distance into perspective. By dropping the entire planet Earth right next to the storm, you can see that this single weather event could comfortably swallow our home globe whole. But scale is only part of the equation. There is also the question of its distinct, unnatural hue. Planetary scientists trace this color to a photochemical reaction. When ultraviolet light from the sun bombards chemicals like ammonium hydrosulfide in the upper atmosphere, it creates these vivid rust-colored compounds, and those compounds are locked in place. The storm is pinned between two massive jet streams blowing in opposite directions, acting like a giant planetary conveyor belt that constantly feeds momentum into the rotation. A frictionless environment combined with extreme atmospheric chemistry inevitably produces an anomaly of this magnitude. As we breach the perimeter and push through the outer clouds, the visual field turns dark and violently chaotic. Out here on the edges, the winds scream at over 400 miles per hour, generating forces that would instantly shred the strongest Category 5 hurricanes we record on Earth. Unlike flat ocean storms, this vortex is a deep cylinder. It plunges hundreds of miles straight down into the crushing pressure of the lower atmosphere. Deep inside that pressure cooker, colossal lightning bolts discharge across the void, electrical strikes carrying enough voltage to scorch a terrestrial continent. This schematic illustrates the storm's power source. Earth's hurricanes draw energy from surface water, but this vortex feeds on planetary heat rising from Jupiter's core. That relentless thermal upwelling provides vertical thrust, pushing against gravity and preventing the deep walls from collapsing. It is an incredibly efficient thermodynamic engine, locked in a cycle that perpetuates its own extreme violence century after century. Pulling back through the cloud deck, we ascend away from the deafening winds and return to the dead silence of space. Looking down at the dark, blue-toned southern pole, we can see that the Great Red Spot is not an isolated event. Deep, swirling vortexes scar the entire globe. On Earth, weather is fragile. It breaks apart against mountains and fizzles out over cold water. Here, the weather is the planet itself. It is a silent, ancient mechanism operating exactly as the laws of physics dictate in the freezing vacuum of the outer solar system. Our atmosphere shields us from this reality, but watching the Great Red Spot turn reminds us that the universe's most powerful engines operate on a scale that renders our terrestrial existence unimaginably small.